Okay. Excuse me. Very similar to your homework or your Bellwork problem. Initially, if you struggle with this a little bit, replace those cosines of thetas with x's and look at the problem this way. That might help you to factor this a little bit better. So in this case, this problem would factor to 2 times the cosine of theta plus 1 times the cosine of theta minus 1. Okay, once you have that, you can split this into its 2 parts. So that means that 2 times the cosine of theta is equal to a negative 1, which means divide by 2, so you get a negative 1 over 2. So when is the cosine of theta a negative half? So that would be a negative 1 here, and hypotenuse of 2. So that's a 60-degree angle. So that's pi over 3-ish. So how many pi over 3's do I have? 2. So it means that theta is 2 pi over 3 plus multiples of 2 pi. Also, you can have answers from being in quadrant number 3. So 2 pi over 3 isn't the only answer. The other answer comes from, what if your pi over 3 passed 180? You would be at 4 pi over 3 plus 2 pi k. Okay, I'm going to leave it at that point because I'll have to list them here in a second. So how do I know again that this is a, hey, you have to list all the answers? Because it says this thing over here, right? So anything between 0 and 2 pi I have to list. But that's only part 1. The other part then would be that the cosine of theta could equal 1. So when does that occur? When theta equals? The cosine is equal to 1 and the x, so that would be at 0, which is the only spot, right? It's one of these rare numbers. It only has one answer. Plus 2 pi k. And then you can list your answer. So keep in mind you need to be between 0 and 2 pi. So because of that, you can't add 2 pi or 2 pi here because you'll be past. So 2 pi over 3 and 4 pi over 3 are 2 of your answers. And then the original problem said that you could include 0 as your answer. So 0 is included, so that you list 0 as your last one. And I don't really care what order you list them, but this would be one way to do that. Anybody have questions on that one? Alright, let's look at the next one then. So if the sine of theta is x, this would be x squared minus x equals, well then cosine must be what? Can't be an x, so that would be like a y squared. So here's a problem. You can't leave the cosine squared or the sine squared like this. So one of these two you want to replace so that everything is written either in terms of sines or cosines. Because you have a sine here already, replacing this with a cosine squared doesn't do you much good, right? You'd still be stuck with and a sine and a cosine. The one that you will want to replace is this one. You will want to replace the cosine squared because the cosine squared could be written as 1. Okay, so that's what I want to replace. So I don't do much here yet. And then I'm going to plug in 1 minus the sine squared of theta over here. So now I just have like x's with sine of theta being my x. So add sine squared, so that gives me 2 of these, minus the sine of theta, bring the 1 over, sorry, minus 1 equals 0, and that looks a lot like what I just had, right? That's 2 cosine squared minus cosine minus 1, so it's the same pattern except now you have a sine. So this is 2 times the sine of theta plus 1 times the sine of theta minus 1 equals 0. So when's the sine of theta equal to the negative half? That would be when theta equals negative 1/2. So that y has to be a negative, right? So you're here, So that's a 30-degree angles here, so this is a pi over 6. How many pi over 6 do I need? 7 pi over 6, right? So 7 pi over 6 plus multiples of that. Well, I don't really need to worry about the multiples, do I? Because I can't add 2 pi to that. It would be too much already. So what else do I have? And 11 pi over 6. And theta could also be 11 pi over 6, because on this side I would still have a negative 1 here. So 11 pi over 6 is another possible answer for the first part. And then you need to worry about the sine of theta equaling 1. And when does that happen? When theta equals pi over 2. And pi over 2 only, right? It's one of these exceptions again. Because otherwise it would be a negative 1. So 7 pi over 6, 11 pi over 6, and pi over 2. So this one has 3 answers again. Okay, so combining a little bit of factoring with your trig identities and then just solving. Can I move on? So when you have a mix of sine squareds and cosine squareds, see which one you want to replace so that you have everything in just one of them. So either all sines or all cosines. Alright, so how's that one different? What I have here that I haven't seen yet? 2 theta. Okay, do you know something that you can replace that with? Yes, 2 sine theta cosine theta. So when you have 2 theta here and just a theta there, you would want to write this all in terms of thetas. Okay, then what? Alright, well what you want to do here is bring over that cosine of theta to the left. So write it this way. Then cosine theta is common, so take it out. And that means you get cosine of theta is equal to 0. So when's the cosine 0? That would be at
0.
Not 0, it would be 1 there. Pi over 2 and 3 pi over 2. And the other one would be the sine of theta. So move the 1, it would be 1 divided by 2. When is the sine of theta equal to a half? When theta equals? We just had it over on the other side. We had a negative half. I think it's a pi over 6, right? Okay, for those of you that are not sure about that, let me draw the picture. So 1 here, 2 is your hypotenuse, that's a pi over 6, right? And 5 pi over 6. Because it would also happen over on this side. Okay? What you don't want to do here, because sometimes people do this and they don't get why they can't get the right answers. So some people will say, well, just divide by the cosine of theta. So that one cancels, that one cancels. You just get 2 sine of theta equals 1. So you do get the sine of theta equals a half. But what are you missing? What part are you missing? What happened to this one? Okay, don't divide by variables. Divide by numbers, but not by variables. Okay, so don't solve by dividing here. You will not get all the right answers. Okay, we just saw this trick, and there's another reason this one's in here. So what can I do with the sine squared? Keep in mind that I already have a cosine here. Okay, so that becomes a 2. That looks better if this was a positive cosine squared. So cosine squared of theta minus the cosine of theta. That would make this a negative 2, so when I bring it over I get a positive 2 again. So I just rewrote it so that it looks pretty. Okay, is this factorable? X squared minus x plus 2? X squared minus x plus 2? I don't think it's factorable. So what you can check though is the discriminant. So when you get something that's not factorable, just check your discriminant real quick, because usually the following happens. They sort of made it non-factorable on purpose. So you need to do b squared, so negative 1 squared, minus 4, a is 1, and c is 2. What do you get out of this mess? 1 minus 8 is? And what does a negative 7 tell you? No real solutions. And in this case, theta supposed to stand for what? Stands for rotations. So this one doesn't have any answers. Okay, you got to have rotations. Now they can be positive or negative, but we can't do imaginary rotations, so you don't have to worry about imaginary answers here. So after you've sort of replaced it and written everything with cosines, and you don't see a factoring, check the discriminant. Maybe it's one of these. Okay, so I don't want you to sit there and waste a lot of time trying to figure it out when that simple little check gets you to the answer. Alright, how about that one? Wait, what can you do there? Anybody? We could change it. We could do that, but that's going to give me a lot more work than the other thing that you can do. Does this ring a bell? Would it be the cosine of 2 theta? Yes? Don't forget that occasionally you can work this way. And the square root of 2 over 2 is also 1 over the square root of 2, right? So when is the cosine 1 over the square root of 2? That's pi over... What's pi over 4, right? So 2 theta is pi over 4 plus 2 pi k. So theta must be pi over 8 plus pi times k. And then I do need the other one here. So it's a cosine, right? So if the cosine of pi over 4 works, then it also would have worked over here, wouldn't it? And that would be how much? Yeah, but I don't want to start with a negative, so I'm going to start with 7 pi over 4 plus 2 pi k. Divide by 2, so you get 7 pi over 8 plus pi times k, and now I can list them. So it's pi over 8, comma, and pi can be written as 8 pi over 8, right? So the next one would be 9 pi over 8. And then after that would be 17 pi over 8, but 17 pi over 8 is more than 2 pi, so I don't need to list that. And then I list 7 pi over 8, and 7 plus 8 is 15 pi over 8, and that's almost 2 pi, so anything else will make it past 2 pi. So there are 4 answers here. Yeah? And then we have one really mean one left. Okay. This is going to take me a little bit of writing. So, first step is to do this. And I'll give you some choices. The trick here is to end up writing this as the sine of alpha plus or minus another angle, or a cosine of alpha plus or minus another angle. So what does this one remind you of a little bit? When it says sine minus cosine. Anybody? Anybody with their sum and difference formulas? Which one does this look like a little bit? Not any squares, please. Just the pattern. Which pattern does it look like a little bit? With the cosine, we always start with a cosine times a cosine minus a sine times a sine. So I could make it look like that, but then I'd have to make this a negative one. Does that make sense? And that would have worked. What I'm saying is, if this had been the cosine of theta, minus the sine of theta, but then this would have to be a negative one. Then yeah, I would say this is the cosine of alpha plus beta, because it would fit that pattern, but that's not the one that I have here. So since we're having trouble with this, what does this pattern end up looking like? You guys okay with that pattern? It's in here. Now I need to cheat. And so this is called the 1 over the square root of 2 trick. And a while back I mentioned that we would run into this. This was when we dealt with a tangent, and I rewrote once in this manner as well. So what I'm going to do here is I'm going to divide everything by the square root of 2. Okay, there's a 1 here and there's a 1 there, right? So if I divide by the square root of 2, I get this. Are you guys sort of with me dividing everything by the square root of 2? I'm going to rewrite this a little bit. So this is the sine of theta times 1 over the square root of 2 minus the cosine of theta times 1 over the square root of 2 equals 1 divided by the square root of 2. So let's see what we have. Alpha must be what? Alpha is theta, right? I don't know what beta is yet, but I can tell you that the cosine of beta has to equal what? Yeah, the cosine of beta is 1 over the square root of 2. So beta is what? Pi over 4. And here it says that the sine of beta is supposed to equal, and this is why it works, because that only leaves me with one unique solution for beta. Beta is pi over 4. Do you guys sort of see how I can find out what the missing angle is for this? So that means that this left side could be written like this. This is the sine of theta minus pi over 4, and that's supposed to equal 1 over the square root of 2. So now I have one more thing to solve. Theta minus pi over 4 is supposed to equal what? When is the sine equal to 1 over the square root of 2? That's at pi over 4. But keep in mind that that's only one of them. So pi over 4 would be a possible answer. The other answer would be here. That would be at 3 pi over 4. So theta minus pi over 4 could also be 3 pi over 4. Are you guys okay with that part? Then solve. Theta would be pi over 4 plus pi over 4, which is pi over 2. And I don't have to worry about multiples here because I only have one theta, so anytime I add 2 pi to this, I get too much anyway. And here, when I add pi over 4, to get rid of that one, I get theta is equal to pi. So the two answers are pi over 2 and pi. And it all comes from this nasty little trick over here. Now, that little trick, it doesn't necessarily have to be 1 over the square root of 2, but it works for 1 over the square root of 2 because pi over 4, the sine and cosine for pi over 4 are worth the same. Okay, but you can create problems like this that deal with some of these other special triangle ratios that you have, like 1 over the square root of 3. Or 1, that's fine, because the tangent of pi over 4 is 1. And square root of 3 over 2 would be another one that you might need to look out for. So this is, like I said, this is a mean little trick, but I think it's in your homework assignment, so you might have 2 or 3 of those. Not a lot, but you will see it.